Algebra 1, Lesson 99, Uniform Motion, Unequal Distances. Why am I so blurry? Let's focus in here. There we go. Cool. So uniform motion, unequal distances. What this is talking about is our distance problems, but we're going to find out that the two distances that are being traveled are unequal. Meaning that in our problem, someone will either have a head start or they won't actually catch up to the other person. These are normally like chase problems where one person is chasing another person, or one train is following another train, or someone left their keys at home and so their brother hops in the car and tries to catch up to them. I'll show you an example really quick. We'll do this one because this one's pretty simple. It's a good way to explain what's going on. So they say Rachel began 15 kilometers ahead and they ended up in the same place. Okay, so the distance diagram is this. So who is they? Who's the other person? Man. No, oh, that's not the actual problem. Sorry, hold on. Bad example. Let's go to this one. We'll go to 99.3. Okay. It says Harry and Jeanette jog around a circular track that is 210 meters long. Jeanette's rate is 230 meters per minute, while Harry's rate is only 200 meters per minute. In how many minutes will Jeanette be a full lap ahead? Okay, so they want to know how long it's going to take Jeanette to be a full lap ahead of Harry. So the diagram we're going to draw here, and remember that the track is 210 meters long. So 210 meters long. So the distance here is going to be, they're both starting at the same point, and eventually the distance of Jeanette is going to be much farther than the distance of Harry because he's a slow runner. And she will be one full lap ahead of him, and they tell me that the lap is 210 meters long, so the distance she will be ahead of him is 210 meters. And I'm blurry again. What's going on today with this camera? There we go. So we have distance of Harry, 210 meters, distance of Jeanette. So the way we're going to set this equal in our equation is we're going to put that the distance of Jeanette is greater. So that would equal the distance of Harry plus 210 meters since he is the slowpoke. The next step, like all of our distance, rate, time problems, once we have our distance equation, we're going to rewrite it in terms of rate and time. So instead of distance of Jeanette, I'm going to put rate of Jeanette times time of Jeanette is going to equal distance of Harry times time of, or sorry, not distance, rate of Harry times time of Harry plus 210. Now, the cool thing is, since they both started at the same time, and we want to know how long it's going to take for her to be 210 ahead of him, they're both traveling the same time. So, in this rate and time equation, we can say that time of Jeanette is equal to time of Harry, or both the times are the same, which means we can eliminate the subscripts. There is only one time being used. Now we have to figure out the other equation. The other equation says that Harry's rate is 200 meters per minute and Jeanette's rate is 230 meters per minute. So if rate of Harry equals 200 and rate of Jeanette equals 230, we can plug these in, and then all we have to solve for is time. So we have 230 times t equals 200 times t plus 210. So now we solve for t. We'll subtract 200t from each side. That's going to cancel. This will leave us with 30t is going to equal 210. Divide each side by 30. Can cancel the zeros, and 3 goes into 21 7 times. So 7 minutes is going to be our answer, because we want to know how many minutes it's going to take her to lap him. Let's see here. We'll do one more example. Let's see here. The other example, so in case you're having trouble with these or in case that example doesn't quite work with whatever you're dealing with on your homework, we've got this one. At 8 p.m., Achilles left the camp, headed south at 20 kilometers per hour. At 10 p.m., Patroclus headed south from the same camp. If Patroclus was 50 kilometers ahead by 3 a.m., what was his speed? So in this problem, Achilles and Patroclus are both leaving the same camp in the same direction. So we have distance of Achilles, he's leaving the camp, and then Patroclus leaves the camp and then passes Achilles, and he's 50 meters ahead of him. So this distance right here is 50 kilometers. So we'll start by writing the distance equation, which is going to be distance of Achilles plus 50 is going to equal the distance of Patroclus. And then after we're done writing our equation, we're going to substitute it for rate and time. So this will be rate of Achilles times time of Achilles plus 50 equals rate of Patroclus times time of Patroclus. Now we go to our problem to see what information we have that we can fill in here. It says Achilles left the camp at 8 p.m. and Patroclus left at 10 p.m. So Patroclus left 2 hours later. And then if Achilles left at 8 p.m. and the time we're guessing from is 8 a.m., we have to count how many hours it is from 8 p.m. to 3 a.m. So 8 p.m., so we've got 9 p.m., 10 p.m., 11 p.m., 12, 1 a.m., 2 a.m., 3 a.m. So 7 hours. So Achilles' time is 7 hours. So I can go over here and I can put time of Achilles is equal to 7. Now it says Patroclus didn't leave until 10 p.m. So if we count from 10 p.m., we've got 11 p.m., 12, 1, 2, and 3. So his time is 5 hours, or 2 hours shorter. So time of Patroclus is equal to 5. So that's two things that I can substitute in. That's pretty cool. What else do we have here? Oh, it tells me that Achilles left the camp at 20 kilometers per hour. Okay, but they don't tell me the rate of Patroclus. So I can put that the rate of Achilles is equal to 20. So I've got 3 solid things I can plug into this equation. That'll give me only one unknown. So let's go ahead and plug these in. So rate of Achilles is 20. Time of Achilles is 7. That plus 50 is going to equal the rate of Patroclus times his time, which is 5. So I'll simplify. 20 times 7 is 140 plus 50 equals 5 times the rate of Patroclus. 140 plus 50 is 190. Now we divide each side by 5. And 5 goes into 190. Let's see here. I'm just going to use normal old division this time. 5 goes into 19 3 times. 15, 4, 0. 5 goes into 40. 8 times 38. So 38 equals the rate of Patroclus. And that is our answer, because that's the only thing we're missing from this equation. All right, that's it for this lesson. If you have any questions, let me know on Moodle, and I will see you in class.